Hello everyone, and welcome to the series about machine learning. This is part 4, and it's about clustering. In the previous lessons, we've talked about setting up your environment, which covers setting up your development environment on Amazon Web Services. Second part, we talked about an introduction to machine learning, and we covered classification using KNN function. And the third part, we talked about regression, where we covered linear regression, SVM regression, measuring correlation, RBF kernel tuning, and finally testing accuracy. So why do we use clustering is one of the topics that we'll be covering. Another is clustering examples. When do we use it? Retrieving stocks price for Google. So we'll be working with the stocks. We'll also talk about visualizing the prices, working with many stocks, and finally the clustering part, which is finding similar stocks within the stock data. So first we'll generate this text that takes us to the Agenti administration interface. These are the username and password. Make sure you change them on your instance because you don't want anyone to access your Agenti interface. So why do we use clustering? Unlike classification and regression, clustering is unsupervised. That means the algorithm will classify your data not based on predefined categories. The algorithm will look for similar data points in your dataset and cluster them together. Different algorithms can solve specific problems, but k-means is a general use algorithm, and that's what we will be covering in this tutorial. Clustering can be used for a very large number of purposes, but I will be talking about three main things. Finding similarities between items with no categories. So if an example would be categorizing text documents. If you have a large number of text documents, you can categorize them based on common words or things like that. You can count objects in an image. That's useful in biology, where they are counting sometimes cells or things in hundreds or thousands of images. Grouping images based on content. That's used to find similar images to the one you're looking at based on the colors of the image, basically. Finding new patterns in categorized data. So sometimes we want to understand some features that we don't. We can cluster them and see what we get. Or finding correlated stocks and commodities. This is what we will be doing in this tutorial. Finally is the recommendation systems. Finding related news articles. Actually, Google uses that to show related news articles to the one you're looking at once you're searching. And finally, finding products or information according to a user's taste. So an example would be YouTube. You will get a list of videos on your homepage that YouTube thinks you like based on your watch history and other people's with similar watch history. So let's start by importing our libraries. I'm importing Pandas as PD, NumPy as MP, matplotlib.pyplot as PLT. Then I'm importing some other things in here. I'm importing Candlestick, quotes historical Yahoo, and date to number from matplotlib.finance. These are we'll be using these to do some functions for stocks. I'm importing k-means from scikit-learn.cluster and I'm importing normalize from scikit-learn that pre-processing. Finally, I'm importing date time and time delta from date time. So let me execute that. I will be configuring Pandas to display a maximum of 50 columns because we are working with a large data set in here. I'll start by retrieving stock prices for Google. So I will be defining a function in here called download data. It takes a symbol and a number of days as a delta. And it will calculate your finish date as today, and your starting date, it will subtract the number of days in here. So by default it's 30 days. I'm reading from Yahoo Finance using this function quotes historical Yahoo. I'm passing the symbol that I want to read, start date and end date. Then I'm storing this data inside a pandas data frame, and in here I'm passing the raw data as it came from this function to the data frame, and giving it the name of the columns as I want them um, in my data frame. Finally, it returns your data frame. In here, I'm calling this function with the symbol GOOG, which is Google's symbol in NASDAQ. In here, I have the first column in underscore date, which is a numerical a representation of dates. I have open, which is the opening price of the day, close, closing prices of the day, high, which is the highest price for a deal during that day, and low, which is the lowest price of the deal during that day. Volume is the number of shares traded during that day. In here we have 19 rows, so we have 19 days within the last 30 days, which were trading days. I'll start by processing the date just to make it humanly readable instead of this thing. So I'm defining a function here called process date. It takes data set and it's first it converts end date column to an integer column because we need it to be an integer. By default it's a float. Then it applies date time that from ordinal, which takes this number and converts it to a date. And I'm calling this function. So we have the result of that in here, and we can see it generated our dates. Then I'm calculating daily average, daily change, and range. There are a lot of things you can calculate. You can calculate moving averages and other things if you want, but I will be just working with the basic things in here. I'm calculating average as close plus high plus low divided by 3. This is one way to calculate the daily average. Some people work only with close as a representation for that day, but I find this to represent the day in a much better way. It doesn't include the open, which is the first price of the day, but it encapsulates how much did the market went up and down. So if it closed closer to high or low, it will still show that it moved through the day between high and low. And a close will influence the price a little bit more. It's just one way to calculate it. You can use whatever you want, or you can use close instead of that. Anyway, I'll be calculating the change amount, which is close minus open. So how much did it change during the day? Change percentage, which is change amount divided by average. Then I have range, which is high minus low divided by average. Then I have change from 1 of n. So if I want to calculate the change from 1, which is the change from previous of a record. It equals the average of that record minus the average of the previous record. Change 1 percentage of n is change 1 amount divided by average. I'm defining a function here that does exactly this, and this is the code to do it. It's just simple pandas and mathematics in here, replicating this these formulas. And I can see my results in here. I have the average. So the average of this day is this. Change amount, change percentage, range, change from 1 amount, and change from 1 percentage. Putting the first 1 to 0 because I don't have the previous record. So that's just one way to do it. Visualizing the price. I will be plotting the price, and I'm using plot date function from matplotlib, and I'm formatting the x-axis to show dates on the x-axis like that. So that's the average price of Google during the past 30 days. You can see it went a little down, up, down, then again up. But that's one way to look at it. Sometimes we want to add more data than just a single line. We can plot different things on a twin axis x-axis. So it will maintain the x-axis and generate a secondary y-axis. And here I'm plotting the average price and the change from 1 in percentage using a secondary axis with the twin x function. So I have in here 2 lines. The blue line is the average, and the red line is change from 1 day. I can see this is the percentage for the red line. This is 0. And this is the price. This is the y-axis for the price, the blue line. You might prefer to use candlestick charts. Actually, most traders don't like lines like this. They like candlestick charts. So to use candlestick chart, you pass an axis, then you pass a variable called quotes, which is a sequence of time or date, open, close, high, low. You can have more things there, but it will not look at your other variables. Then you can have an up color, down color, and an alpha. I'm using green and red for up and down, and I'm modifying the width to 0.6 to give it a little volume. And we can see now Google is in a candlestick chart, so it shows more information than a single line. We can see that some days it moved more than others. That you cannot see that in a single line chart. We can also use twin x function to generate a secondary axis and plot another a chart with our candlestick on a secondary y-axis with a twin x-axis. Working with many stocks. In here I have a list of 50 stocks. They're mostly tech stocks: Google, Facebook, Apple, Microsoft. I have some media. I have some other things in here like GE, ExxonMobil, Caterpillar, and I want to download their data now. So I defined a dictionary in here with the symbol and name of each company. I'm storing symbols in variable name symbols and names in a variable named names. Um, I'm starting a new data frame in here named stocks data, and it just has the symbol basically, and I'm adding a second column in here with the name. So we have an easy reference to um, our symbol and name. I think it didn't show the results, so that's normal. Whenever you have this, save your notebook. Once you get checkpoint created, just go to the address and reload your notebook, and that will get you back to where you were. Um, so I'll go down to the same one and I'll execute it again, and you can see it's working now. I have symbol and name for each of the 50 companies that I'm working with. So I have 50 rows, 2 columns. I'll be downloading this data, so I'll be looping in here. I'm first downloading data using our function to download data. Then I'm processing date, calculating stats, then adding the symbol to this data. And I'm appending all of that in a list and concatenating this list using pandas concatenate. So if we execute that, oh, that was fast. And it returned in here a list of, it's a data frame with all our daily prices. In here I have Netflix, then Apple, I think that's New York Times, Facebook. So I have all of these different stocks now in the same data frame, and this is exactly what I want. I will be visualizing multiple stocks, so I'll be visualizing. Um, I'm using X as date and Y as the average price, and I'm plotting all of that using just a simple loop. And I have some stocks in here between $500 and $600. Have a second one here, and have a bunch of stocks around 100, between 0 and 100 basically. Um, that's if I wanted to find information about which stocks are similar, um, it will be really hard to do it just by looking at them. So we'll be this is where clustering comes in. It will help us find similar stocks within this data set of 50 stocks. Um, so first, I'm defining a function that will pivot our data. So it will take this data set with all of these readings and pivot it in a way that dates are columns now, and the um, symbol of stock is the index of each column. So I have rows, index of each row. So I have one row for Apple, and it has columns for each of these days. In the numerical interpretation of the date. Um, Normalizing the data. I don't want to talk too much about normalizing data because we'll be covering that in details in the next tutorial. But assume that you have your data in here, which is your data set. It has 2 dimensions, so I and j. This is the mathematics of this. I don't want to confuse you with the mathematics, but basically it will normalize your data between any 2 numbers. In here, if I look at this, my data goes from around 600 until 0. I can normalize all of this data and make it run between, for example, 0 and 1 or -1 and 1. That's really useful to find similar stocks. So this is how our data looks normally, and this is how our data looks if we normalize it on the x-axis, basically. Um, it moved all of the stocks in single range to show how did they move relatively to each other. In here, it's useful if I want to look for stocks with similar prices, but in here it would be very useful if I want to look into stocks that are moving together. But it's really hard to still find any stocks in here. I have 50 lines tangling with each other. It's really hard to do this manually. So this is where clustering comes in. I'll be defining a new function, cluster data. It takes a data set, it takes number of clusters, and it asks if you want to normalize your data or not. So in here I will be doing that. And did the same thing again. Save. Wait for it to give you a checkpoint created, and just reload. It's a little annoying, but you learn to live with it. Anyway, um, perform clustering. I have 8 clusters because I told it to create 8 clusters. And in here I can see that it added a new column to my data set named cluster, so I can see the first and second stocks are in the same cluster, and the fourth one also. This is in a separate cluster, cluster number 3, cluster number 4, 5, 3, 3, 1. I can see that different stocks were grouped into different clusters. So let's visualize these clusters. And here I'm defining a new function called visualize clusters. It will take a data frame, the value that you want to cluster with, the number of clusters, and whether to normalize your data or not. It's calling pivot cluster data. It's taking your data back and generating a new data frame for it. And it's putting the prediction back as a new column in your data named cluster. Then it's just plotting the cluster centers, which are called centroids. Then plotting the actual stocks. Let's execute that. It will make more sense once you see the actual charts. So in here I'm clustering using the average. I told it to create 3 clusters, and I told it to normalize our data. So these are basically the 3 most general things that happen to these 50 stocks in the past 30 days. This one just went flat, the green one. The red one went a little high. The blue one went high, then flat, or went a little down near the end. So let's see what it has for us. The first group has BlackBerry, Salesforce, HP, Rackspace, and they are the group that went really high, the blue group. And this line represents the centroid of this group. The second group has really a lot of stocks, Autodesk, BP, and a bunch of other stocks. It just went, I think, a little down. And these went a little higher, but not like the blue one, Apple, Adobe, and a bunch of other companies. To have more control over that and to test different ideas, we need to see what works and what doesn't. Again, the same problem. Save. So I'm defining a new function in here that measures how successful the clustering is. It measures the distance between all of these points and the center and takes the average of that. Let me and the second thing it does, it counts how many failed clusters. So any cluster with a single stock won't be counted. Let me just load this again. Just give it a second to load. It's getting heavier and heavier as a notepad. Okay. And finally, it's measuring how many failed clusters. So basically, any cluster with a single stock. Any cluster with one stock, it doesn't tell us anything. It just tells us it doesn't match anything in our current model. But it doesn't tell us anything beyond that. So we call that a failed cluster. So let's test. I have an average error of 0.007, and I have 0 failed clusters in this one. Tuning using widgets. So this is really useful. Sometimes you want to have a simple slider where you can just move it around and get different results. And this is exactly what we're doing here. You can change which feature you're clustering with, how many clusters you want, and whether to normalize data. In here I can see I have some failed clusters. One, two. I have I have 2 failed clusters and have an average error of 3.2. I can test something else. I can change it to, for example, if you're working with close, not average, you can say, well, I want to cluster by closing prices. And in here, it's clustering your data into several things. That's not really good clustering, but you can normalize your data and get better results. You can lower the number of clusters to 4, and you can see that we get much better results in here. We have 1 failed cluster still. Anyway, so how do you search for the best number of clusters? In here I have just a simple loop. It's looping over whether to normalize your data or not, and it tests different number of clusters. In here, I told it to cluster, to try up to 30 clusters, and then it's plotting the results of this. Let's run that and see what we get. It's just taking a second to run, and this is exactly what we're looking what we want. You want to see the average error going lower and lower as you increase the number of clusters. So this is a normalized model looking at feature of average. The error goes lower and lower as we increase the number of clusters, which is the x-axis. This is the average error, and this is the number of failed clusters. So failed clusters are the blue line. Usually you want to look at the intersection and look around it and find a good point around the intersection. So if I would train a model to cluster these, I will be looking at 15 clusters. That gives me less than somewhere around 7 or something like that. 7 failed clusters out of 50 stocks. That's a good one. But if I was doing that for if I didn't normalize my data, so I'm just looking at different price ranges, I can see that the error goes really down, goes down really fast in here, and it stabilizes after that. So I would go with somewhere around here, somewhere around 20 clusters to show how many price ranges I had for my stocks. If you have any questions, leave them on this video or contact me on Twitter or Google Plus. And this lesson is available open source on GitHub, and it's viewable on MBViewer. The link to this is in the description box below. Feel free to use this for any purpose you want, or as a reference whenever you're working with k-means or clustering. Um, I hope you enjoyed this tutorial, and if you like to see more of this, please subscribe to this channel and watch the next part of this series, and it will be about pre-processing your data. Thank you for watching.